for joining. As Emily said, what I plan to do today is assume, frankly, no basic knowledge at all. Start from the fundamentals of CQRS and event sourcing. Tell you a little bit about Axon. Not too much. I know that's not the principal focus here, so I won't spend too much time there. I'll only spend just enough time to give you a basic flavor of the Axon API and how it models CQRS and event sourcing. I'll also talk to you a little bit about how these concepts and Axon in general maps to and why it's relevant in a microservices domain. And we'll spend a little bit of time with just a little bit of code examples talking about sagas and basically Axon's concepts of distributed base transactions, if you will. So managing transactions not in an ACID way, but in a base fashion using this concept or design pattern called sagas. Okay, so if you have any questions, feel free to ask me like in line. I think that's honestly better because I can simply answer those questions in line, like as I'm going along, as opposed to maybe having an out of context discussion later. So feel free to just stop me, and we can have a chat if we need to. Okay, so without further ado, let me get started. So I'll start with why CQRS. Give you a basic of what CQRS is. CQRS stands for Command Query Responsibility Segregation. Command Query Responsibility Segregation. It's a bit of a mouthful, and honestly, I don't know who came up with this. It's a very kind of nasty sounding acronym, but the concept behind it is not that, honestly, in my opinion, is not that hard. Some of the APIs are a little bit hard. Some of the ramifications of what this stuff means are a little bit hard, but the basic concept, I think, is actually relatively simplistic. So CQRS has its roots in this particular observation. So I think most of us that have been, that at least have some exposure to enterprise systems, it's not unusual in an application to see this sort of queries. So this one has 22 joins and 6 subqueries. I can very easily tell you, unfortunately, something like this, whether it's generated code or handwritten code, is not out of the ordinary in most systems that have a little bit of legacy and a little bit of complexity. So the real question where CQRS, the main motivation behind it is trying to understand why this occurs and is this normal? Is this something we should accept, or is there a better alternative? And the answer in the CQRS world is that there is a better alternative, and the theory behind CQRS is that these sorts of queries occur because we are trying to do too much with a canonical model. So in other words, we have a single model in our application, and then we're using that model to get too much out of it. So we're trying to model the domain using that model, model the business domain, execute our changes or commands in CQRS parlance against the domain using that model, and we're also trying to use that model for querying, and often the queries are not that easy and not as clean and neat as we like it to be, because users and the legitimate business needs are just complex in terms of how you want these your business model to be visualized. So it winds up causing this problem of having these very complex and more importantly, kind of slow-running queries, because most of these queries, it's difficult for most relational databases to be able to execute these queries in a very efficient way. So then what is the answer? So the answer, one answer is CQRS, of managing this problem. So what you do here is that you simply acknowledge that you're trying to do too much with a single model, and you break up the model in two distinct pieces, actually more than one, more than two pieces, but let's say, logically speaking, two different pieces. So what we're saying here is that we'll execute all of our writes, meaning changes to the system, namely additions, updates, and perhaps deletes, using a single model, and that model looks very much like the kind of model that you would wind up with if you were sort of a first-year a graduate student and you are told, hey, go model the system. It's very much close to the how the domain model will look like, business domain model would look like. That's how the right model is going to be. And we send all of our commands from whatever our interface is. Typically, it's a UI. It doesn't need to be a UI. It could be essentially all of this could be microservices, and the UI could be really a set of services. But essentially, all changes to the system we categorize as a command, and we route those commands to the right model. In addition to the right model, what we have is a very specialized read model that maps one-to-one to every single view that we have. So however we want to slice and dice and represent data, we have a model for that, a view for that, if you will. So that constitutes our read model. So it's a bunch of views of our write model, if you will, very specialized to specific cases, such that these queries can be as something as simple as select so-and-so field, or ideally select star from whatever this view is, and then that's pretty much it most of the time, and there'll be just some simple where clauses, and that's pretty much it. So it's literally, the read model consists of what's called a table per view. So every single view of the data essentially translates to a single specialized table whose only purpose in life is to serve that query. So then the question becomes, well, how do you keep, if you have two different models, how do you keep these in sync? Well, one benefit of this model is that all of the changes occur via commands to the right model. So what that means is the right model is the owner of the changes. So what you can do is figure out some way of materializing and identifying those changes that occur in the right model, and make sure that the read models or models are synchronized with that, so that they can pull out these queries in real time. And obviously how real time depends on what technology you use for materialization and what techniques you wind up using for materialization. And we'll talk a little bit more about this when we talk about the event sourcing part of it, and certainly the Axon part of it as well. This could still be ACID if you absolutely need it to be. So this materialization phase could happen in the single transaction. The read could happen in a single transaction, but that's not typical. The more typical case is that this is actually done in an asynchronous, eventually consistent fashion. So the read model is not absolutely guaranteed to be 100% reflection of every single change in the system, but it's close enough to be functional for most systems. And it's just something you need to live with if you decide that the writing efficient queries is to be solved using this particular technique, CQRS, right? So that's the principal reason why you would want to consider this pattern. But there are some other benefits as well. So, and this goes directly to our microservices discussion that we'll have a little bit later. But basically what this means is that if your read model and write model is logically separated, ideally maybe all the way down to the database, and you're using two different physical databases altogether for reading and writing, that means that you could scale these independently. So for example, if you have a high number of reads and a low number of writes, well, you could assign lower number of nodes and lower vertical hardware limits on the right side, whereas you have higher vertical scalability metrics and more hardware, more nodes on the read side of the equation. So that's another benefit that you're getting out of this model, and again, that goes towards increasing general scalability and performance of the system. Similarly, you could use the correct data storage for the read on the right side. A very typical situation for us actually is that the right side, as we will see in a second, is actually a specialized database, something similar to NoSQL, if you will, but a very specialized database to maintain the right model. And often the read model is something efficient to the end user purposes. So typically this will be relational databases because they're good at doing things like joins and filtering and ordering and the like. They're optimized for solving those problems. But it doesn't necessarily need to be that way. It could be just about anything else that you can imagine that's appropriate for that read model. For example, it could be something like a log stash, or Kibana, or Elasticsearch, or anything else of that nature. And this allows you to do that. This allows you to dump the read data into the exact most optimized storage the strategy that's needed for that particular query. Okay, I think I heard a question, so I'm going to stop for a second. I guess I must have misheard something. So I'm just going to keep moving. And again, I do encourage you to just ask me questions as we go along. So the last and frankly most important from our observation at Axon is that CQRS is important because it enables event sourcing. You can do CQRS without event sourcing. In fact, some people do. They, for example, use just regular database triggers to materialize, to synchronize between the read and the write side. But the opposite is just not possible. If you say you actually what you're really after is event sourcing, CQRS almost becomes a necessity. There's no other way, there's no other known way of making really event sourcing work without also introducing CQRS. So that's why CQRS and event sourcing are often talked about together. It's rare that they're actually used separate from each other. Okay, so with that, let's talk a little bit about what is event sourcing really, and when do you use this particular pattern. Really what event sourcing is that it's a way of storing data. It's a way of looking at how you store data. So the canonical way of storing data is really, if you will, the relational database. And more importantly, snapshot views of your domain model. So what you're looking at probably in most naive implementations, in fact, probably most implementations of data, that is you're answering the question, well, what is the current state of the application? So let's take a look at, for example, users, a table of users, or a table catalog of books, or anything else like that. What you're really asking is, okay, what is the data right now, right? And in most cases, that's what you are asking, and that's a legitimate default, right? That's more appropriate for most situations. In event sourcing, though, that's not how the data is stored. In event sourcing world, what is actually is stored is every single change that ever occurred to that piece of data as a stream of events. And the events here are really relevant events that are relevant to the business. Right? So if you looked at the actual materialization of what is stored in an event source database, and you have a single event sourced entity, if you will, what will actually be stored is every single change that was made to that entity that is relevant to a business. So this, for example, if we take an example of, let's say, a bank account, what would be stored in an event source database is things like account created with an amount of $100. Account was debited for an amount of $5. Amount was credited for an amount of $20. Interest was paid. A bank transfer, a account transfer occurred, etc., etc. Similarly, for if you were to look at, for example, a user record, what would be created is things like initial user record created with the username, password, such and such. Account was updated. The user account was updated. Passwords was changed at this timestamp by this user. So this is the kind of thing that is actually stored in an event sourcing case, right? As opposed to the actual end current state. What you're actually getting is a history of what happened to the data from the beginning of time. So the question is, why would you want to do this? What is the benefit of it? Clearly, there's some trade-offs here. Number one is the complexity trade-off, as well as things like the storage trade-off as well. So in this case, you'll be storing, again, every single change that ever occurred to a piece of data. So the reason that there's a few reasons you want to do that. I'll discuss that in a second. But what I want to do is do the tie-up now between CQRS and event sourcing. So let's say, for sake of argument, that you have a right model, a business model, a domain model that is going to use event sourcing. So this data is event sourced. Well, the problem is event source data is not very easily readable, especially if you're trying to execute queries, right? So imagine going after a piece of data like, okay, so what is the current account balance? It's not really practical for you to look into the entire history of that account to figure out what the current balance is every single time you need to do that. So the solution to this is to introduce CQRS. So what you have is a read model that says, this is my current bank balance, or whatever it is that you need to know from that event source bit of data. You have as what's called a materialized view of that data. And the way you synchronize between the read and the write model is using those events that are stored in the event store. So as you are literally recording an event into the event store, you'll also publish that event out into a bus. And anyone that's interested is going to read from that bus those events. And in most cases, what they will do is they will materialize the read model or materialize the views that correspond to queries that you need to execute in that. And the query model could look very, very different from the write model. In most cases, they do. They're not very similar looking. They have two different purposes and look very different in CQRS applications. So that's the tie-up between event sourcing and CQRS. Other than that, the rest of what I said previously for CQRS holds. Okay, so let's now get back to why would you want to do this. We know why we want to generally use CQRS, namely it's principally for enhancing the performance of a complex system. The reasons for using event sourcing, on the other hand, are often business-driven. There's a business reason why you want to do event sourcing. And in fact, for Axon users, it is actually, most of the people actually start with event sourcing as a need, and they use CQRS as a side effect of that fact. So the most common one is that these sorts of systems often have a need to maintain an exact audit trail of their data, right? So they may need this principally for audit trail for regulatory purposes. They're simply legally required to store every single data every single data change that occurs in their system, or that is the nature of the data to begin with. So, for example, all kinds of general ledger problems, like for example, the bank account example that I was using, those naturally fit into an audit trail or general ledger problem. But there are cases where, for example, there are financial systems where a regulator can ask you, well, how did the system change occur? And you need to be able to answer those questions. And CQRS is the most efficient way of doing that because it's literally baked into the design pattern of how you solve these problems. In, for example, very mission-critical financial or legal situations, you also need the CQRS model because you can, again, at any point in time, not just answer what is the current state of the data, but you can answer exactly why the data is the way it is, going all the way until the beginning of time. So there's some other benefits to the event sourcing pattern. A big benefit that a lot of our users actually take advantage of is something called temporal reports. So if you were to create temporal reports in a system that doesn't use CQRS, you can do it. But what you need to know is you need to know what your reports are going to look like and what you are after beforehand. If you know that you need, for example, monthly sales figures, right? You can easily create those reports. What you can do in a non-event source system is do these reports on an ad hoc fashion. So it's very difficult to produce these numbers after the fact if you haven't been doing them, and then suddenly you're asked, hey, give me your monthly sales numbers for 3 months ago. Well, you can't do that because you don't have that data anymore. So event sourcing really comes in handy in these sorts of situations because your data is stored in its most basic atomic format, and that means that you can produce any kind of temporal report at any given time snapshot at any given time, at any moment. Similarly, it's very helpful for analytics. Often in analytic situations, you don't know what you're looking for until you begin digging. So again, having the raw information of what precisely transpired is very, very helpful. In analytic situations, there are cases where there's folks that are basically reading the event logs and feeding those systems into some kind of AI big data processing engine and producing analytics from those artifacts. So one nice thing that, again, this ties back into more of the reasons for using CQRS is that event sourcing in general produces very efficient writes because every single change in the system is actually simply an append to the end of the event log, right? So that means that your writes are as fast as possible with minimal locking, really. So it's not you never need to update any data, and you never need to actually delete everything. You simply keep appending to the state of a given entity, and this helps to reduce the latency time, especially with CQRS, because your writes are extremely fast, and you're basically very quickly generating a whole bunch of events that can be then be synced with the read model as quickly as possible, with a minimum amount of locking, either on the certainly not on the write side, and even on the read side. It's relatively easy to scale your system out. It also allows for some design flexibility. So what this means is that because your read models can be effectively just deleted and restarted from scratch, you can have generally, as long as you don't change your right side of your domain model too much, you have a lot of design flexibility because the other side, the read side, effectively the visualization of your application, well, that can be as flexible as possible. You don't need to determine a lot of things to begin with and determine a lot of things later. Okay, so an interesting question that we always wind up answering, probably for you guys, it's more obvious, the answer to this question. But often what we're asked is, okay, so why do I want to use, these are just design patterns, CQRS and event sourcing. Do I really need your software, or do I really need your framework to implement it? Couldn't I just do this myself? Well, you can, right? Probably if you have very, very basic needs, you can kind of sort of get away with doing this, but you won't go far because there's simply far too many nuances. So things like consistency and storage requirements, event distribution, event ordering. There's a lot of underlying nuances that are actually not that easy to implement, and there's other benefits that you get, other design patterns that you can benefit from once you have basic CQRS in place. These are things like managing deadlines, managing timeouts, sagas, which we'll talk about in a second, and a whole bunch of other features that you would just have to recreate from scratch over and over again. So the principal purpose why you would want to use Axon is that you would reduce your boilerplate quite a bit. So all of that code that you would hand write over and over again yourself, well, you don't need to do that because there's a framework, and that's a framework that's shared across other people as well. It's not just something that you're writing in-house. So generally, it's a more robust production-ready solution than what you would probably write out by hand and maintain by yourself. The other nice thing about Axon is it does come with an API, and we'll see the API in a second. And the API basically constrains you to some extent, right? So if you're wondering, well, how does this CQRS and event sourcing patterns look like in practice? Well, you wonder no more, because in Axon we basically are telling you, like, this is how the API should look like. So it helps for teams that don't need to reinvent the wheel, and can simply just use the Axon APIs as guidance on how to implement CQRS and event sourcing. The other nice thing that Axon does is that it separates infrastructure from the API, and again, this is a familiar concept to most Java EE folks, because in the end, what you're dealing with in the application is just the API, and all of the rest of the stuff. For example, the configuration of the event bus, whether the event bus is local or spread across a network, whether the event listeners are in the same JVM or another JVM or another data center, or whether you're using NoSQL as the underlying data source for your event sourcing database, or you're using relational databases. What is your ordering semantics? How do you manage transactions? All of these things are actually just Axon configuration, rather than something that you necessarily need to code for. The Axon configuration, again, will be familiar to Java EE developers. It's very high-level abstractions, and most of the configuration is actually just completely decoupled from the code. And one of the nice things that this gives us, and I'll talk about this when we talk about in a second about microservices, is that it allows for this notion of location transparency. So in the end, the code doesn't care where the listener or where the command handler or where the event bus is located. It could be on the same JVM, it could be somewhere different. It doesn't really matter. You can determine those parameters later on and reconfigure your application without changes necessarily to your APIs or your core domain model or business logic. Okay, so I'll put this all together. I'll start showing you some code here. So the code is up there. I'll show you the GitHub example real quick and show you how that looks like. But basically, it's an example very similar to sort of the bank account example that I've been using. It's yet another domain called a gift card. I think we've all used gift cards. You get issued them for a certain amount, and then you can go redeem them at a store. And that fits, again, the CQRS event sourcing use case domain problem relatively well.
So Reza,
yes.
Can I ask you something? Yes. So for your Axon, is this the kind of the backend you can plug in Kafka? So I see you have the event handling Kafka event handling consumer. Is this because like Kafka streams can also do the CQRS and etc. So like I mean, how do you interact with Kafka?
Okay, so Kafka actually is not very good as a mechanism for storing event source data. The reason for this is that in order to do event sourcing, and I'll show you this in code in a second, something you need to do is rehydration and materialization of your entity state. And in Kafka, that's not very easy to do. So in order to reconstitute a single entity, right, you would have to read the entire stream and filter out all of the data from a stream pertinent to that particular entity instance before you would be able to rehydrate it. So for that reason, Kafka is actually not very good for as an event sourcing database. What it is good for is an event distribution mechanism. So in a sense, it would be more along the lines of using something like ActiveMQ with Axon. And the purpose of ActiveMQ would be to, once the event is stored, how do you distribute them to listeners? That problem Kafka solves extremely well and solves in a very, very scalable fashion. So if you, for example, if you had millions of listeners, Kafka wouldn't have any problem handling that, whereas most other messaging solutions would. But it's not a very good solution for event storage. I'll show you a quick example. Thank you
Okay.
for mentioning that.
Thank you.
It's a little bit of a distraction, but I'll show you Kafka
Yeah.
event.
Hello.
Yes.
Yeah. So hi, I'm Renato. This is the first time that I'm joining here. So I work for Lightband together with James. And so to what Reza just said, I just want to add one thing. I totally agree that Kafka, it's hard because as Reza was saying, when you want to rerotate your entity, you want to only read the events of that entity. That's very important, which is something that a Kafka topic don't allow you to do. And because we are talking about microservices, so what Reza was saying about Kafka, a very good fit to propagate events from my service where I produce them and where I consume from my read side, but I can also consume those events there to put in Kafka so other servers can consume. And then I remove the strong coupling between two servers because now they depend on the broker and not on each other. So that's a pattern that we promote very much and we use very often with our community. That was
okay.
A comment.
Great, thank you.
For anyone interested, I would welcome you to take a look at this blog entry. It's very well written, and it's not specific to any technology. It's not like they're trying to make a pitch for Axon, what Axon is saying. This is an independent person, and it's logical. There's nothing. I mean, if you take a look at it from a rational, reasonable standpoint, you'll understand why Kafka is really not a very good event sourcing model. But anyway. I just wanted to put that out there. Okay. And anything else, Emily?
Yeah, that's great. Thank you.
Okay. All right. Okay. So let me show you the gift card example real quick. Let me see if I have it in here somewhere. Apologies. I should have had this up already. It's on my personal GitHub. So I have, after we're done here, you can just go to this, and it's embedded within the slide deck that I already sent out to the alias. And you can actually set up this code yourself. There's instructions on how to do that. So you can do that after the fact without me really. So right now, this is using Spring Boot. This demo is using Spring Boot. The reason is, honestly, that's what most of our user base is, and the talk that I'm giving you and the good example I'm giving you is actually the ones that I present at conferences. So it's Spring Boot, but it doesn't need to be. We also have, I just wanted to also let you know, we have CDI support for Axon as well. So everything that I'm saying here, you could do and rewrite in CDI if you so wish. So Axon works perfectly well with CDI and Java EE. In fact, we have customers that are doing exactly that. They're using Axon with CDI and Java EE application servers. So there's nothing stopping you from doing that. So but for this particular example, I didn't have time to translate, create a clone and port everything over to CDI. For this, I'm just using Spring Boot. Don't make too much of it, please. It's just a technology for as far as Axon is concerned. You could use any technology. For example, you could use neither and use just Java SE, and Axon would work fine there as well. Okay. So let me start the application. Oh, I'm sorry. That would work, but there's no reason to do that. I'll just do this instead. Apologies. Something is going on with my machine. And typically, this is not this slow.
That's a typical demo behavior. Every time, like when you do demo, the weird thing will happen.
If it was working fast, then you should care, because then it's not normal to happen.
No, it's not
working
normal.
A demo, no?
Yeah, I think what's happening is I just did typically I turn off my virus scan because it's really painful if you're doing development and your virus scanner is like scanning every single change that's happening in the system. I think I just did a Windows update last night. It probably turned my virus scanner back on. Normally it's not like this. Anyway, okay, right. So that's that. So here's my Spring Boot application. I'll take you through it very quickly here. Okay, so here it is. It's nothing too fancy. It's just bare minimum of what's necessary to sort of show you the basics of CQRS. So let's issue two different cards. So I'll issue two cards, and I have two cards here. The IDs were assigned, as you can see. So I'll take one of them, and I'll issue the card ID, this card ID, and I'll say I'm going to redeem this card for, oh, let's say $10, and I hit submit. And as you can see, it's reduced by $10. So not rocket science. You could do this using a CRUD API. Certainly, there's nothing, I suppose, theoretically wrong about doing that per se, or rather technically wrong with doing that per se. But in this case, we are using event sourcing to solve this problem. I'll show you that in a second how event sourcing is in play. But basically, this is an event sourcing. It's a general ledger problem. You issue a card, and then you're in this case it's just a redeem. There's only one type of action that you can do, but it's a subdomain, if you will, of the bank account use case that I was talking to you about. So that's what it is. Demo wise, let me show you what's happening in the database. It's a little bit more interesting, I think. Okay, connecting via H2. Let me steal some code from my GitHub for a second. Okay, so here we go. So taking a look at, hopefully you can reasonably see my screen. Let me see if I can increase the font size a little bit. Okay, all right, so you'll see that this is my database table. So in this case, I'm actually using the same relational database, both for the read and the write side of the application. And I'm using essentially a relational database as the event store, which you can do. It's actually had been the default prior to Axon 4.0. Axon 4.2 onward, we actually use a different specialized data store for event sourcing. But in this case, I'm just using the relational database for both purposes. So if I look at the card summary table, let me show you that real quick, the contents of that. And again, hopefully you can see it. So this is this is the view query per view model that I was talking to you about. This is part of the view model. So as you can see, this is almost exactly what you see in this screen, right? In this part of the screen with the data that you're seeing, this is the table that it comes from, right? So it's a very, very specialized table for exactly for those purposes. And you'll see that there is no card or anything else like that, right? So if you look at the schema here, there's no such thing called card. So where is this data actually coming from? Well, the data is coming from this domain event entry table, and this is where all of our events are stored. So I'll show you how that looks like in a second. So let me show you that, and let's see if I can slice and dice this a little bit better. Okay, so yeah, this is where all of our events are stored, and notice the events that were triggered at this point. So we have the global index event identifier. Metadata is the actual payload in this case. So as you can see, there's a correlation ID. Metadata is internal use of Axon as well. But the payload is what I was trying to tell you about. So in this case, you see that the payload is, we have two different cards created here. And it's two different issued events, and this is where what the actual data for it is. In this case, it's stored in JSON. It could be stored in XML or any other serialization format. Axon actually doesn't care. We have one redemption event. So we redeemed it for $10, as you can see. This is the redeem event against this is the payload, and there's some other data here just to show you that this is in fact what it is. Let me issue another card. So control minus. Okay, and let's do it for $3. So now it's down to $12. I will reissue this query. What happened here? Okay, if I reissue this query, you'll see that now there's a new event here. Hopefully you can see it within reason. This is the $3 again. This is a redemption of $3 here. So this is the event stream, right? This is literally what we were talking about in terms of event sourcing. So let me shut this stuff down. In fact, I don't know if I even need this screen, but okay, we'll leave that alone. Let me shut Spring Boot down as well. Let me start to begin to show you how the data for this looks like. Sorry, the code for this looks like. Let me know if the font is too small. If it is, I'll try to increase the font size. So the most important one here really is where we should start is probably gift card. So gift card is basically our, if you will, this is the right side of our model. Right? So this is the canonical domain model, if you will. This is how our domain model would probably look like if we were just had a card application that doesn't use CQRS and event sourcing. So it's, as you can see, gift card. There's an ID associated with it. You must have an ID for everything that is an aggregate or an entity in Axon. So this actually is being managed by Axon. Right? So this is an Axon annotation called aggregate, and we are essentially managing this aggregate ourselves. So we're managing the lifecycle of this aggregate. So every aggregate must have an ID. In this case, it's just a string. It may have state associated with it, and in this case, we do. We have as you can see, a value called an int called remaining value. And that is basically our materialized state. This is not actually state that's held in the database. It's actually held in memory in this case, and it's materialized into memory. There's various command handlers. So as you can see, as I had told you prior in CQRS world, every single change to the system is a command. So we have two different commands here, just an issue command and a redeem command. Very, very simple. And what we have in the event source aggregate is handlers. Right? So we're literally handling these requests for changes to the system within this aggregate. So we have lived up business logic telling us whether we can actually successfully execute this change or not. And if we can, what we do is something called applying an event in Axon. So what you are really saying is, yes, this is a legitimate command, and I'm issuing an event that represents this change. So, for example, I'm issuing an issue event with this with the ID and the amount, or I'm redeeming an event, and again that has a ID of the aggregate that's being redeemed as well as the amount that it's being redeemed for. And what this is doing behind the scenes is that it is appending to the event store, right? And also publishing these events out. Axon is also making sure that whoever is interested in these events actually winds up with these events. And the actual change, often to the materialized state, happens through another sort of internal event handler called an event sourcing handler. And what we do here is On issue event, we assign ourselves an ID and we assign a remaining value. Similarly, for the redemption, we deduct from our remaining value, and this is actually the only reason we need this is we're using this for in the business logic, right? So, for example, in the business logic here, if we don't have sufficient amount for a redemption, we're throwing an exception and rejecting this event from actually occurring, right? So that's the only reason we need the materializer. Yes.
Remaining value is what, in memory state?
Yes, that's correct.
If there were like two, is it ever possible that there could be two instances of a gift card ran in different JVMs, and so they wouldn't have access to this in-memory state?
Yes, so that's, again, if you were to naively go and implement this, you'd wind up with that problem. So again, in Axon, we try very hard for that not to ever happen. So what we make sure is that there is actually, across the system, only one instance of a gift card with a particular ID, and it actually is handling these commands in the order that in the timestamp order that they actually happen. So yes, it's a very legitimate thing that can happen, but not in Axon.
And a gift card, a gift card would that map to the gift card in the user interface, like the serial number of the gift card? So in the entire running system, there's only one entity that can respond to updates for that particular gift card.
Exactly. Yep. Yeah. That's precisely what it is.
So, okay, but I understood Tom's question on another way, because I had that question that I was waiting to ask at some point. At the beginning of your presentation, you will talk about efficient writes, which I understand that you have a journal that it's append only, so it's very efficient to only append things. But what I understood from Tom's question is, if I have two nodes of an application and I have the load balance, I have two commands coming, and the load balance is send the commands, the request to one node, and the second one is sent to another node. We are talking about having two JVMs. And even if you want in one JVM, you can, Axon, I believe, you can make sure that the commands are treated in order. How do you do that when you deploy more than one instance of your application?
Yep. So what we do with that is through essentially through the event store. So the event store is the ultimate essentially synchronization mechanism that we're using under the hood to do a lot of this. So all of these changes are actually synchronized in the end, right? So not every single change, right? But a change in the scope of a single aggregate instance, that is serialized, right? So we're not attempting, for example, to serialize changes across instances of gift cards, but we are serializing access to a single instance of a gift card, right? So yes, there is some serialization overhead that takes place in the end. Honestly speaking, we actually don't really recommend doing that. So we don't really recommend scaling out the right side of the application. So for example, having multiple nodes that handle changes to gift cards, right? I mean, you could have a scenario where, okay, gift cards is handled by one thing, and then user changes are handled across another node. But we do recommend scaling out the read side by all means, right? There's nothing stopping, and there's no need not to do that.
It's not that you have some kind of optimistic locking that will make sure that only one of the commands would succeed, and that's not the case, no. You don't.
That's not the case. This is not. Yeah, this is okay. Very much.
So that's why I brought this the topic about efficient writes, because if it was optimistic locking, although it's still very performant because you are only hitting this one table, but you are not doing append only anymore. You need to read and then append, which is also performance, but less than if you are only doing really append only. No? So okay, I got it. So it's not recommended to scale up the right side. That's the recommendation. Okay.
But just to follow on from that, I didn't understand how, if you did choose to scale up the right side, and they're both, the two instances get an inconsistent view of the remaining value of the gift card, which allows it to verify, validate successfully on line 44 for both the instances. They both process a redeem event for $10 simultaneously. It wasn't clear to me then how the element, the component that you mentioned that I can't remember the name of, that seats could on the you mentioned some other component that could somehow, I don't know, I'll not put words in your mouth. If you've got the two instances and they're both checking remaining value and they're both okay with the remaining value of $10, but in fact it would allow the card to go negative, what part of the system were you saying would reinforce that?
Okay, so Tom, in Axon, there's never going to be two instances, two object instances of event handler with the same ID. There's only going to be one instance. So what happens is so let's talk. This is jumping ahead a little bit, but let's talk about that. So this command handler, right? This command comes from somewhere, right? So the command can only actually be issued by through the command bus. So I'll show you where that comes from. So the command bus is here. Gift card UI. You see the command gateway here?
Yeah.
So when we issue a command, this is how it winds up ultimately to an aggregate, right? So it's this line here, command gateway dot send and await, right? This is actually a Axon artifact. This command gateway is being injected from Axon. So this command gateway is aware of every single node that exists in the system, and where each of these aggregates actually reside, right? So it makes sure that only the right only a single across the system, right? Because basically this artifact, the command gateway, is going to be shared across the system, even if it's a distributed system, and it will land the command with the correct ID to the correct instance that there is only one of across the system.
Yeah, I see. Just to follow up on, I think it was Renato was saying then, is it possible, I know you said it's not recommended, but if you did want scalability through load balancing, and yeah, I appreciate you're saying that basically the instance that handles the ID is not replicated, but maybe the gift card functionality can be replicated. Where would the load balancing actually occur? Is it something inside of Axon itself?
Exactly. Yeah. It's within actually the command handler itself,
right.
The command bus itself. It takes care of the load balancing and routing and the like. So it does load balance across that, though, just so you know. So it's not like a single. If you did have multiple instances and you choose to do that, this is going into the weeds a little bit. But basically, it makes sure that it's not just one node that's handling every single request that comes in for gift card aggregates. It could be spread. It's typically spread across, sort of like round robin, across multiple nodes. So node 1 will have ID 1, node 2 will have ID 2, etc., etc.
But then that component, I forgot the name, is a kind of dispatcher. It's leaving one of the nodes, or each node. Each node,
yeah. There's an agent on each.
If a node receives a command, they need to know, okay, that entity is not living here, it's living in another one, and then it forwards to that other node.
Exactly. Yeah.
Okay. Cool.
Okay. Anything else?
So aggregates are typically stored in memory, right? And what happens if the aggregate is too large to store in a single JVM? Like you have 100 gig worth of aggregate data. You just solve that by breaking it apart into multiple nodes?
We've never run across this issue. So an aggregate is just really a visualization of a single instance of a single table, if you will. I think it would be an anti-pattern to, I mean, typically you're talking about production fairly large machines. I think you'd really have to do something awful to come up with an aggregate that would take up
Well,
the
the
entire JVM.
the aggregate stores the current state, right,
Yes.
of all objects of that type. So if I have a billion gift cards, I have to store them all in memory, right? The current
That's
state of
correct.
those billion gift cards.
Yeah,
That's
but
true.
yeah, but an aggregate it's one gift card. It's not
I see.
all the gift cards from your system.
But you're right, yeah. If there's sufficiently large numbers of them, yes, you would probably run into a situation where you would absolutely need to have horizontal scalability to store essentially sufficient number of gift cards. Yes, that's true. But also, I'll have to look into this in particular. I believe we also have a passivation policy, so we don't. I don't think we hold the instance of gift card in memory forever. I believe we time them out, but I'd have to look into that.
And does it only need to store in memory the stuff that it needs to validate? Because it's the write side, didn't you say? So
Yes.
it only needs to store in memory. It doesn't need the content of what's been. If someone's uploaded a CD, it doesn't need to store the CD in memory. It just stores metadata in order to validate subsequent updates. Enough.
I
That's
find
correct.
it pretty much correct. It's very often people don't. The first time people use the CQRS, they tend to put on the aggregate all the model, but it's the only thing that must be there is what we need to validate the commands that come in. And lots of data that are useful for the system goes into the events, and then you use them on the read side, and you produce the reports and whatever you want on the other side. So like I upload an image, it goes to the other side. It does not need to stay in the aggregate. Just an example. Yeah, it's pretty much correct. I agree with that.
So the aggregate, I just trying to understand. So the aggregate is kind of the accurate, is up to date information, right?
That's correct. Yes, this is atomic. This is ACID more or less.
Right. Okay.
So the gift card is more or less.
Yeah, but this is the kind of aggregate the current view, but the events will go to the backend, and then the event will be processed, and then eventually it will be persisted in the data store.
Right. So if you're familiar with the EJB serialization mechanisms, Emily, there is a parallel to that. So notice these event sourcing handlers. So what happens is these are triggered every single time an entity is rehydrated. What actually happens is all of the events since the beginning of time are actually issued against this entity before it is put into service, right? So it actually is reconstituting the current state from the event stream each time the entity is loaded via these event sourcing handlers. So it's a bit of a nuance at the moment, but I think that may be pertinent to what you are asking. So it's not as though these event sourcing handlers are just invoked only for the things that have happened going forward, but it's basically triggered for every single thing that has happened in the past as well, before the entity before the aggregate is actually put into service into the system. So Emily, we're out of time.
Yeah.
So how do we handle this?
Yeah.
I can keep going. We can stop for today and restart another day, whatever you prefer.
Yeah, I think we should stop for today, and then I think I can see we can have a continued discussion for 2 or 3 times. How about we reconvene like next week? No, not next week. The week after next week, same time. Is that going to be okay?
Yes, it's fine.
Okay. What about the others? Okay. Okay, that's cool. I will kind of put a message on our like micro profile like announcement there, and then we will see, and then yeah, we can reconvene the 2 weeks time. Okay, great. Thank you so much, Reza.
You're gonna sorry, Emily. You're gonna upload this to the microprofile channel as well, YouTube.
I will give the video to you and let you to upload.
I'm fine with that. I'll upload it.
Okay, I'll give the video to you, and then yeah, you will upload it. Okay, great. Thank you.
Yep.
Yeah, great. Thank you all.
Thank you.
Yeah, thanks.
Especially Reza. Thank you so much. Okay, bye.
Thank you.
Bye.
Bye.
Bye-bye.